All right, guys, good morning. Welcome back to another video. We're continuing on in chapter 8, so section 8.2.2, using what we know about factoring and the preliminary stuff that we talked about, parabolas, in the last video. We're going to talk about a big thing in algebra called the zero product property and how it applies to parabolas and what you can do with factoring, how it all ties together. So let's just dive right in. We know from the first question that there's no calculator allowed, so everything we're going to do here is going to be by hand. So which is kind of a nice thing, and then as we go on into future sections, we'll be able to use the calculator to speed some of this stuff up, but it's nice to get a base idea without the calculator. So let's start right away. It says 8-64, what do you need in order to sketch a parabola? So how many points do you need in order to sketch a parabola? Do you need 1? Do you need 10? Do you need 50? We'll think about these questions below. A sketch does not need to be exact. The parabola merely needs to be reasonably placed with the points clearly labeled. So since we're doing things by hand, it doesn't have to be perfect, but as long as the points are clear, we can get a rough idea what the parabola looks like. We're just trying to do some sketching. So again, sketching does not have to be perfect. So let's dive right in. In part A, it says, can you sketch a parabola if you only know where its y-intercept is? For example, if you knew a parabola had a y-intercept at 0, -15, would you be able to sketch it? Why or why not? Well, let's say that we have this graph over here, so we have some place to sketch. So I'll kind of move this up a little bit. And if I was going to plot the point 0, -15, notice x is 0, so I'm not going to be moving right or left. I'm going to start at the origin, no moving right or left. -15 means go down 15. So if I go down here, I go down 10. You'd say there's not enough space, but we can keep going. There's 11, 12, 13, 14, 15. We could imagine it's somewhere down here. And if this is the only point that I had, would I be able to sketch a parabola? Well, no. What if the parabola is facing up or down? I have no idea or no way of telling. You know, it could be a parabola looks like this. It could be a parabola going down this way. Just having a y-intercept would not be enough to say what a parabola looks like or be able to sketch it. So in this case, why or why not? Can we sketch it? We could say no. There is not enough information to know what the parabola looks like. All right, so we'll write that in there. Let's keep moving. So then if we move on, I'll fold my paper so that we can see the bottom questions. So then here it says, what about the two x-intercepts of the parabola? If you only know where the x-intercepts are, could you draw the parabola with that information? For example, if the x-intercepts are at -3, 0 and at 5, 0, can you predict the path of the parabola? So let's graph these really quick. Again, that was a y-intercept. It was supposed to be on the y-axis if we extended the y-axis downwards. These are going to be on the x-axis. They are the x-intercepts. How you know that is because the y-coordinate is 0. So how would you graph -3, 0? Well, you start at the origin. I notice that x is -3, so I'll go left, 1, 2, 3, and then notice the y-coordinate is 0, so you're not going to be moving right or down, or right. I'm sorry, you're not going to be moving up or down at all, so you could just pull out a point here at -3, 0. How about 5, 0? Again, you start at the origin, the x-coordinate is 5, so you can move right, 1, 2, 3, 4, 5, because 5 is positive. The y-coordinate is 0, so you're not moving up or down at all, which makes sense. You're talking about an x-intercept. These 2 points should be on the x-axis. So what if I just had these 2 points? So if I just had these 2 points, would it be enough to predict the path of the parabola? Could I sketch the parabola with just these 2 points? Well, no. We run into the same problem as we did with the y-intercept. What if the parabola is facing upwards? If it's facing upwards, I would get something like this. But if it's facing downwards, I could potentially get something like this. So would I know for sure with just the x-intercepts what the parabola looks like? Well, no. So in this case, you can say no. Again, there is not enough information. So what do we know so far? We know that if we're just given a y-intercept, that there's not enough information to sketch a parabola. If you're given just the x-intercepts, there's not enough information to sketch the parabola. So how about part C? Can you sketch the parabola using x-intercepts and y-intercepts? Let's test the idea. Sketch the graph of a parabola for the quadratic equation y equals x squared minus 2x minus 15 with roots -3, 0 and 5, 0, and the y-intercept of 0, -15. Well, the y-intercept of 0, -15 we already have here. The x-intercepts, -3, 0 and 5, 0, we also already put down on the graph. It does introduce this idea of this roots. I want you to put down on the paper that roots are the same things as x-intercepts. And it turns out there are some other words that you can use for x-intercepts as well. So roots are x-intercepts. You could also call x-intercepts solutions. You could also call them zeros. So there's actually 4 ways to describe the same thing in math, depending on what you're talking about. You could talk about x-intercepts, which is where a graph hits the x-axis. X-intercepts are the same things as roots, and they are the same things as solutions and zeros. So in math, these 4 words will mean the same thing, just depending how you're talking about them is which word you'll use. So we have everything that we need. Can we sketch a parabola now that we combine the x-intercepts and the y-intercepts? Well, we know the y-intercepts by themselves is not enough. The x-intercepts by themselves is not enough. But if I combine the two, if I have x-intercepts and y-intercepts, then I should be able to graph. Because look, here if I have the x-intercepts, I'm curious, is the parabola facing upwards or downwards? Well, if I have this y-intercept, then I know that this has to be a point on the parabola, which means the parabola has to be facing upwards. It would have to look something like this. Another thing that kind of helps out is the fact that you can use a vertex. We know a vertex has to be halfway between x-intercepts. We learned that in the last video when we were doing the balloon toss. We knew from where the person tossed it to where it landed, the highest point had to be halfway in between. So what if I was going from -3 to +5? How many units are in between -3 and +5? Well, there are 8 units between -3 and +5. So if there are 8 units between the two, then halfway would be 4. So if I go back 4 from 5 to 1, I could also go up 4 from -3 to get to 1 as well. So I know that that would have to be the vertex or the highest or lowest point on the parabola. Okay, so to get a rough sketch of what this looks like, very much like we did some sketching in the last video, I like to put down the line first, and then to make it a little bit nicer to see or easier to see, you'll just go back in and shade in the line a little bit to make it a little bit darker, to make it a little bit thicker. All right, so if I combine the idea of x-intercepts and y-intercepts, it looks like I should be able to sketch parabolas, which is kind of nice because up to this point, from what we saw in first semester, we would have to make those tables. And the tables were a little bit tedious because you'd have to find a whole bunch of values for x, plug them into the equation, and it would take a couple minutes to do. I remember some of you were not too fond of it, so this will speed things up a little bit. The last question they have here is, where is the line of symmetry? We know the line of symmetry has to go through the vertex. We did just say the vertex is halfway between these 2 x-intercepts. Halfway between these 2 x-intercepts is at 1. So if I draw it in, we can draw it in here like this. So then how would you write that line of symmetry? Well, it's a vertical line, so it would have to start with x equals. What x value does it go through? It goes through 1. So in this case, you can say your axis of symmetry is x equals 1. Again, axis of symmetry, or the vertex high-low point, has to be halfway in between the x-intercepts because parabolas are symmetrical. So halfway between -3 and +5 is +1, guys. Okay, so a big thing to take from the first example, if you have x-intercepts and y-intercepts, you can graph parabolas. Okay, very good. So let's take this idea and let's keep moving. So the next question we have is 865. And then it says here, in the last problem, you learned that if you find the intercepts of a parabola from a rule, then you can sketch the graph without a table, which is nice because that means less work. We don't have to make the table. What is true about the value of y for all x-intercepts? What is true about the value of x for all y-intercepts? Review your knowledge of intercepts and describe it here. So if we go back to our picture that we established in the last question, what could you tell me for sure about the x-intercepts? Well, the x-intercepts, or the roots, were -3, 0 and 5, 0. What's true about both of them? What do they have in common? Well, the thing they have in common is that the y-coordinate is 0. So if you want an x-intercept, or a root, then the y-coordinate has to be 0. So we can write it here. We can say for x-intercepts, the y-coordinate must be equal to 0. All right, so we have that. If I go back to my picture, what can you tell me for sure about y-intercepts? Well, if I have a y-intercept, that means it has to be on the y-axis. What's the value of x on the y-axis? Well, it's 0, right? So here I have 0, negative 15. That means the x-coordinate is 0. So similar to what we said for x-intercepts, in x-intercepts, the y-coordinate must be equal to 0. For y-intercepts, the x-coordinate must be equal to 0. Now we've seen this before, but maybe it's been a while, maybe you forgot. And these two little things will end up unlocking the intercepts for us, which means that the graphing of the parabolas will also get easier. So how could you sum it up? Whichever intercept you're looking for, let the other coordinate be equal to 0. So if you're looking for an x-coordinate, let y be 0. If you're looking for a y-coordinate or a y-intercept, let x be equal to 0. Okay guys, so how about part B? If x is equal to 0 at the y-intercept, which makes sense because like we said, in the y-intercept x is 0, find the y-intercept of y equals 2x squared plus 5x minus 12. Well, if you're looking for a y-intercept, you could let x be equal to 0. So then anywhere you see an x, let's just replace it with 0. So here I would have y equals, now for 2x squared, but instead of x, I'm putting in 0 squared, plus 5, instead of x, putting in 0, and then minus 12. So it would look something like this. All right, well, let's just go down the line. We know in the order of operations in PEMDAS that we should do parentheses, exponents, multiplication, division, and then adding and subtracting. Parenthesis-wise, there's nothing left to do inside the parentheses, but I do see some exponents. I have 0 squared. So if I wanted, I could write this as y equals 2 times 0 squared, which is still 0, plus 5 times 0, minus 12. Now let's handle the multiplication. Well, 2 times 0 is 0, plus 5 times 0 is 0, minus 12. 0 plus 0 minus 12 is negative 12. So in this case, y equals negative 12. I do want to write the y-intercept as a point. I think that's a good habit to start doing. So in a y-intercept, we knew y-coordinate, which is the second coordinate, is negative 12. What did we plug in for x? We plugged in 0. Therefore, the y-intercept is going to be 0, comma, negative 12. All right. Part C, since the x-intercept occurs when y equals 0, write the equation that you would need to solve to find the x-intercepts for the graph of y equals 2x squared plus 5x minus 12. Okay, so in the last one, we saw x was equal to 0, so we plugged in 0 for all the x's. Now, in part C, they're telling us that y is equal to 0. So in a very similar fashion, just plug in 0 for all the y's that you can see. So instead of saying y equals this equation, I can say 0 is equal to 2x squared plus 5x minus 12. And again, 0 equals 2x squared plus 5x minus 12 is the same thing as 2x squared plus 5x minus 12 equals 0. I like to write it this way. Put the 0 on the right-hand side. Again, if two things are equal, it doesn't matter how you write it. You could write it from left to right or from right to left. So this is the equation that we'd have to solve. Now in part D, it says the roots or the zeros. Take a quick second. Do you remember what roots and zeros are? What is another way to say a root and a zero? Roots and zeros are x-intercepts. So if I'm looking for the roots or the zeros or the solutions, the x-intercepts of a quadratic expression, they are the values of x that make the value of the quadratic equal to 0. Which kind of makes sense. If I'm letting y be equal to 0, we know that for x-intercepts, the y-coordinate is 0. So by solving this equation and finding values for x that make it true, in essence, I would be finding the x-intercepts. I'd be finding the roots. I'd be finding the zeros. So these are the x-intercepts of the quadratic function is a root. At this point, would you be able to solve this for x? So if I gave you a 2x squared plus 5x minus 12 and set it equal to 0, would we be able to solve this equation right now? Could I just add over 12 and then I get x by itself? In this case, no. This is actually something that we haven't done yet. And the reason why we wouldn't be able to solve it right away is because of this 2x squared. I could add over the 12, but then I wouldn't be able to get x by itself because notice here this is a 2x squared and here is 5x to the first. So at this point in time we wouldn't be able to solve this equation, not just yet. So I'd say not yet, but then I'll put dot 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 because that's exactly what we'll do in the next question. We'll get to see an example and see how it works. All right, so this one is complete. Let's keep going, guys. The big idea of the day, 8-66, the zero product property. So let's go through this one and see what happens. There are a lot of examples, but they go kind of quickly. All right, zero product property. The equation that you wrote in part C of problem 865 is called a quadratic equation. So again, just a quick refresher. Why would this be called a quadratic equation? Well, it's quadratic because it has an x squared. Do you remember what form this is in? This is in standard form because it goes in order, highest exponent to lowest exponent. All right. To solve it, you need to examine what you know about zero. Study the special properties of zero below. So here's the situation. Nathan, Sonia, and Gaston are playing a game where Nathan and Sonia each think of a number and then give Gaston a clue about their numbers. Using the clue, Gaston must tell them everything that he knows about their numbers. So here's the situation again. Nathan and Sonia's first clue for Gaston is that when you multiply their numbers together, the result is equal to zero. What conclusion can Gaston make? So Nathan and Sonia both have a number. They're not telling Gaston what the numbers are, but the clue that they're going to give Gaston is that when you multiply Nathan and Sonia's numbers, you get zero. So if you were Gaston, what conclusion could you say for sure? Again, you don't know what the numbers are, but if the two numbers multiply to zero, what has to be true? Well, at least one of the mystery numbers must be zero. Again, if I have two mystery numbers and I don't tell you anything about them except for the fact that they multiply to zero, well then at least one of them have to be zero, right? 0 times 5 is 0, 0 times 10 is 0, 0 times -3 is 0. But then why do I write the word at least? If two numbers multiply to 0, could they both be equal to 0? Well, sure. So in this case, one of them could be 0 or both could be 0. So how about the next part? Disappointed that Gaston came so close to figuring out the numbers, Nathan and Sonia invite Nadia to join to make things a little bit more interesting, a little bit more harder. Nathan, Sonia, and Nadia all think of secret numbers. So they all, three of them, think of a secret number. And in this time, Gaston is told that when their three secret numbers are multiplied, the answer is 0. What can Gaston conclude? So very similar to part A, but now instead of two mystery numbers, there are three mystery numbers that multiply to 0. Well, if three mystery numbers multiply to 0, what conclusion can Gaston make? Well, at least one of the mystery numbers must be 0. Very similar to what we did in part A. Could two of the mystery numbers be equal to 0? Well, sure. If I have 0 times 1 times 2, that's 0. I could also do 0 times 0 times 1, that's 0. So one of the mystery numbers could be 0. Two of the mystery numbers could be 0. How about this? Could all three of the mystery numbers be equal to 0? Well, yeah, it'd be kind of a lame example or lame mystery numbers if all three of them were 0. But the reason why we say at least is because if three numbers multiply to 0, then one of them, two of them, or all of them could be equal to 0. How about part C? Does it matter how many numbers are multiplied? If the product is 0, what do you know about one of the numbers? Well, here we did two numbers, we did three numbers. What if we did 5 numbers? What if we did 10 mystery numbers that multiply to 0? Well, regardless of how many numbers that we choose, at least one must be equal to 0. So it turns out this special idea that we're talking about in this example has a name, and it's one of the most infamous properties in all mathematics, probably one of the more important ones that you need to know for algebra. It's called the zero product property. Everybody knows what zero is. A product means to multiply. So if you have multiple things that multiply to 0, then one of them or more could be equal to 0. That's simply put what the zero product property is. So if multiple things multiply to 0, then one of them or more could be equal to 0. All right, let's keep going. We're almost done. So 867. Let's investigate how you can use the zero product property to help you solve the quadratic equation from earlier. Again, we couldn't do it before, but now maybe we should be able to. So here it says, examine this quadratic equation, y equals 2x squared plus 5x minus 12. Is there a product that equals 0? If not, how can you rewrite this quadratic expression as a product? Well, here, I can't write it as a product. Obviously, there's some multiplication maybe going on with 2x squared, some multiplication going on with 5x, but it's not something times something else that gives me this. But we just spent a couple weeks talking about factoring. If I take this quadratic expression and use factoring, then I should be able to write this as some set times another set in parentheses. So we're going to use what we know from the last several videos and lessons to try to factor this thing. So let's factor it here on the side. So we'll make a little box. Yes, it's coming back. You make a little X or little diamonds, however you did it. M on top, A in the bottom for multiply and add. Remember, quadratic term goes in the bottom left. Constant term goes in top right. Now multiply these two. What is 2x squared times negative 12? That's negative 24x squared. What should they add up to? They should add up to the middle term, which is a positive 5x. So now you have to think to yourself, what are some numbers that multiply to negative 24 and add up to 5? So if you want, you can pause the video and try it for yourself. Otherwise, if you're still with me, I know it has to be something with 8 and 3. I know one of them have to be negative. Well, which one of these 8 and 3 have to be negative in order for this to add up to 5? Well, it can't be negative 8 because negative 8 plus 3 is negative 5. So in this case, the negative has to go on 3 because 8 plus negative 3 is positive 5, and I can give an x to each one. Again, it doesn't matter where I put these 8x and negative 3x in the box, so I'll put 8x here, and I'll put negative 3x here. As I've said before, you can flip-flop those and you'll be totally fine. So what's the GCF of 8x and negative 12? Well, it will be 4, and it will be positive 4 because 8x is positive. What's the GCF of 2x squared and negative 3x? It's x, and it'll be positive because 2x squared is positive. The GCF of 8x and 2x squared will be 2x, positive because of 2x squared being positive. And then how about here? The GCF of negative 12 and negative 3 is 3, but it will be negative because negative 3x is negative. So how could I write this as a product? Well, I know that if I'm finding the area, I'll do length times width. So in this case, I can say y equals length, which is x plus 4, times width, which is 2x minus 3. Have I accomplished my goal? Have I written this expression as a product? Well, yeah, this times this means to multiply. Multiplication is a product. So now let's continue on. Now that the equation is written as a product, let's set it equal to 0. So again, if I have this, I want to set it equal to 0 to find roots. How do you find roots or x-intercepts? You let the y-coordinate be equal to 0. So then what would I have? I would have x plus 4 times 2x minus 3 equals 0. Now use the zero product property to solve it. Since you know one of the factors must be 0, you can set up two simpler equations to help you solve for x. Use one factor at a time and determine what x value makes it equal to 0. Okay, so look what we have. We have x plus 4 times 2x minus 3 equals 0. I have something times something else equals 0. Well, if two things multiply to 0, what has to be true? Well, at least one of them have to be equal to 0. So if this times this equals 0, then the first thing that could potentially be equal to 0 is the set of x plus 4. So the first equation I'll make is x plus 4. But does it have to be the case that x plus 4 has to be 0? Well, no. If I multiply this and this, the second thing could be equal to 0. So the second little equation I'll make is take the second part and set it equal to 0. So really quickly, just to re-explain, if two things multiply to 0, then one of them or both of them could be 0. So I took the first one, x plus 4, set it equal to 0. I took the second one, set it equal to 0, and then I'm going to solve. So how could I get x by itself in the first one? Well, how do I get rid of a positive 4? I subtract it. So what does that mean about x? That means that x will be equal to negative 4. So there's one solution, one root, one x-intercept, one x value that's going to cause the y-coordinate to be equal to 0. All right, in a very similar fashion, I have faith in you guys. How would you solve something like this? To get rid of a negative 3, add 3. So 2x is equal to 3. Now what's happening with 2x next to each other? Well, that means multiplication. How could you get rid of it? Yeah, use division. So divide both sides by 2. So x will be equal to 3 divided by 2. So there are the two solutions. So that's how you solve an equation like that. Again, we haven't done it before, but you must use factoring. Then you take the two parts, set them equal to 0, and solve for x. So what do these two solutions represent? Well, one of the solutions we had was negative 4, but remember the y-coordinate was 0 because we plugged in 0 for the y, so it was technically negative 4, 0. The other solution we had was 3 halves. What was the y-coordinate? 0. So these are my two solutions. Can you tell me anything about them just by me writing them this way? Well, hopefully you'll be able to tell me that these are the x-intercepts. What's the giveaway as to why they're x-intercepts? The y-coordinate is equal to 0. What is another word for an x-intercept? A root, a solution, a 0. These 4 words, like we said earlier, mean the same thing. So those would be my solutions. All right, guys. We have 2 last examples, and then we're all set. So let's finish them up. So here it says in part D, you now know the roots, also called zeros, of this thing. Can you use the roots to sketch the graph of the parabola? So what did we have? We had from the last example that the x-intercepts were negative 4, 0. So let's write here the x-intercepts, which are the roots 0, so on. Negative 4, 0, and 3 halves, 0. But we know that we can't just graph with x-intercepts. We'd also have to know the y-intercepts. So can I do y-intercepts really quickly? I have this equation. Well, if I want y-intercepts, what could I do to x? Well, I could let x be equal to 0. So if I go back in here, I would have y equals 2 times 0 squared plus 5 times 0 minus 12. For the y-intercepts, remember you just plug in x equals 0. Well, 0 squared times 2 is still 0. 5 times 0 is still 0. So 0 plus 0 minus 12 is negative 12. So how would you write that for a y-intercept? Well, x is 0. Y is negative 12. Okay, guys. So if we have x and y-intercepts, like we saw in the first example, we should be able to graph or sketch. So then I'll start with this, 0, negative 12. So if I'm starting at the origin and the x-coordinate is 0, then you're not moving right or left at all. Negative 12 for a y-coordinate means go down 12. So there's negative 11. Here would be negative 12. All right. Again, I need the x-coordinates in order to sketch. What are the x-coordinates or the x-intercepts? Negative 4, 0. So starting at the origin, would you move right or left? Well, since x is negative 4, you'll move left. Since the y-coordinate is 0, you don't move up or down at all. Oh, this one's interesting. How about 3 halves? Where would you put 3 halves? What is 3 halves as a decimal? Well, 3 halves as a decimal is the same thing as 1.5. So this would be the same thing as 1.5 comma 0. So if I start at the origin, how far should I move and where? Well, 1.5 is positive, so I should move to the right. Where is 1.5? It's halfway between 1 and 2. Again, the y-coordinate is 0, so that means I don't need to move up or down at all. I get something like this. So now that I have these 3 points, is the parabola going to be facing up or is it going to be facing down? Well, it's going to be facing up. I know that it has to go through these 2 points and it has to go through that one as well. So in this case, it would have to look something like this. So let's sketch it in. So something like that. And I know my lines are kind of wavy, and that's why going back and making them a little bit darker will make them a little bit better. So even if your sketch looks a little bit wonky and maybe it doesn't look the way you want it to, by making the lines a little bit darker, it counts for the little mistakes that you made. All right, guys, so something like this. Again, doesn't have to be perfect. All we're doing is sketching, getting an idea what to do with the parabola. And the nice thing for you guys is that we don't have to use a table. Tables are a little bit tedious and take a little bit long to do. This is definitely going to be faster as we get better at it. Okay, so there we have it. Last example, 8-68. So let's see. What does this one say? Can you make a sketch of a parabola from 2 x-intercepts and a vertex? All right, so then really quickly, we'll refresh what a vertex is. What is a vertex? It's a high point or a low point. Another way to describe it would be a maximum or a minimum. If a parabola is facing downwards, then it has a high point for a vertex. If a parabola is facing upwards, it has a low point or a minimum for a vertex. And remember, the nice special thing about these is the vertex has to be halfway in between the x-intercepts. So if I can find the x-intercepts, then I can find the vertex. Okay, first things first, find the x-intercepts of a parabola y equals x squared minus 2x minus 8. Well, if I want to find the x-intercepts, what could I do to y? I could set y equal to 0. So then x squared minus 2x minus 8 equals 0. Could I solve this equation? Well, no, because it's not written as a product. So I need to use my knowledge of factoring. So again, setting up my box and my little diamonds, m and a for multiplying and adding. X squared will go on the bottom left. Negative 8 constant term on the top right. Let's multiply them. What is x squared times negative 8? Negative 8x squared. What should they add up to? They should add up to the middle term, negative 2x. So really quickly, if you want to pause the video, do you know two numbers that multiply to negative 8 and add up to negative 2? Well, how about negative 4 and positive 2? And I'll put an x on each one. Let's double check. Is negative 4x times 2x negative 8x squared? It is. Is negative 4x plus 2x negative 2x? It is. So there goes negative 4x and there goes 2x. Again, you can flip-flop the order if you like. What's the GCF of negative 4x and negative 8? It would be negative 4, because 4 is the biggest thing that goes into 4 and 8, and it's negative because of negative 4x. What's the GCF of x squared and 2x? Positive x, because x squared is positive. How about going down this way? The GCF of these two is just x. How about the GCF of these two? It would be just 2, and it will be positive because 2x is positive. So if I wanted to write this as a product, the product would be length x minus 4 times width x plus 2 equals 0. Well, now we've reached a nice place. Two things multiply to 0. So what has to be true? Well, at least one of them has to be equal to 0. So the first one we have is x minus 4. That could be equal to 0, but does it have to be? No, it could be the case the other one is equal to 0. So take the other one, x plus 2, and set it equal to 0. Again, I just took the two pieces individually and set them equal to 0, because if they multiply to 0, then one of them or both of them have to be 0. So how would you solve the first one? You could add over 4. X could be equal to 4. How about the second one? You get rid of a plus 2, you could subtract 2. So x would be negative 2. So then what do I know? In this case, you can write down here, the x-intercepts are going to be these two values that I found. 4, comma, 0, because I plugged in y for 0. And negative 2, comma, 0. Okay, so let's put them down. Negative 2, 0. And 4, 0. Again, we talked about the graphing, so really quickly, those are my two x-intercepts. Now, how do I find the vertex? Well, the vertex I know has to be halfway in between. So then if I'm going from negative 2 to positive 4, then how many units are between negative 2 and positive 4? Well, there are 6 units in between. So that means halfway would have to be 3. So I can either go back 3 from 4, or I can go up 3 from negative 2. Any way I split it, I know that positive 1 is going to be where the vertex is. So if I want to write my vertex, I know it's going to be positive 1, comma, but then what's the y-coordinate? Well, I don't know. In order to find that, I just have to plug 1 into the equation. Would you plug it in for x or for y? Well, you plug it in for x, because you're saying x is halfway in between negative 2 and positive 4. So what if I plug it in? Y equals 1 squared minus 2 times 1 minus 8. So let's just do it in order. Y equals, what's 1 squared? It's just 1. What's negative 2 times 1? Negative 2 minus 8. So let's put it all together. 1 minus 2. So maybe I'll go here. 1 minus 2, negative 1, minus 8. This is negative 9. So in this case, the vertex is going to be 1, comma, negative 9. So if I go over 1 and down 9, I think it's going to be right here. I now have 3 points. I know the parabola has to go downwards to get through the bottom point. So if I'm sketching, I get something like this. And the nice thing about using the vertex is you know that that's either going to be the highest or the lowest point that the parabola is going to go through. So then it even gives you a better sketch than using the y-intercept, because you know that you're going to have this U-shaped parabola either go through that highest or low points, and it will have to be symmetrical. As a bonus, where is the axis of symmetry? Where could you draw a line to cut this parabola nicely in half? Well, you can cut it in half at 1. And you see the parabola is symmetrical over that. So was it easier to use the vertex or easier to use the y-intercept to draw the parabola? I'm going to say the vertex. And it's actually more accurate. So in that case, knowing how to find the vertex and then using that for graphing will make things easier. All right, guys, take what you know from this video and the things that we've talked about previously. Finish the assignment, submit it onto Cadmus, and I'll see you in the next video. Have a good rest of your day.